topic which we study is electric lines of force. Okay, ma? So, electric lines of force. So, what is meant by electric lines of force? You should have studied previously, no, ma? So, it is one of the technique of understanding the behavior of electric field, or it is one concept of visualizing the behavior and properties of electric field. Okay. So, what is meant by electric field already we have studied, no? What is meant by electric field? Force experienced per unit test charge in that particular point is called as electric field. Clear, ma? So, that behavior of electric field we will try to understand with the help of electric lines of force. Are you able to understand, ma? So, it is a method of visualizing the behavior of electric field. Are you able to understand, ma? So, for example, if I take a positive charge, if it is a positive charge, clear, ma? Then we assume that positive charges will give electric lines of force away from this charge. Clear, ma? So, electric lines of force will be moving away from the charge. From which charge? From positive charge. Clear, ma? So, are actually these electric lines are existing? They are not existing. It is our assumption, that's all. We assume that. So, some lines called as electric lines of force, they will be traveling away from the positive charge. Clear, ma? Actually, there are no electric lines of force. This is our method of assuming the behavior of electric field. Are you able to understand? And we also assume that these electric lines, they are making exactly an angle of 90 degrees with the charge. Clear? Similarly, if you take a negative charge, clear, ma? So, from negative charge towards the negative charge, the electric lines are terminating. Clear, ma? So, they are terminating, they are ending on the negative charge. If they are ending on the negative charge, it means they should have been started from somewhere, no? So, from where they have started? They have started from infinity. Clear, ma? So, they are ending on negative charge, but they have started from infinity. Clear, ma? So, this is how we assume the existence of electric lines of force on positive charge and negative charge. Are you able to understand, ma? And the second point is that the tangent to electric lines of force, okay, ma? So, gives direction of electric field. Clear, ma? What is the meaning of this one? For example, if you draw a tangent, clear? For example, this is an electric line of force. Clear, ma? Electric line of force need not be always a straight line. It may be a curved line also. So, this is the electric line of force. Let us consider. Clear, ma? So, to this electric line of force, I will take 2 points, point A, point B and point C. Clear, ma? Point A, point B and point C. So, at point A, point B and point C, I want to calculate what is the direction of electric field. So, what is meant by direction of electric field? Direction of electric field means what? E value. E value means what? E value is force experienced per unit test charge, no? This is called as E value. Clear, ma? So, for example, if I place a test charge here at a point A, then this test charge will experience a force in which direction? How can I indicate that direction? That direction is given by just drawing a tangent to this one. Clear, ma? So, this is the direction of electric field at this position. This is E dash. Clear? E1 dash, or let us call it as. Similarly, at point B, I want to calculate the direction of electric field. Then again you can do one thing. Then again you can draw a tangent here. This is the direction of E2 dash. Similarly, this will be the direction of E3 dash. Clear ma? So what is E1, E2 and E3? So this is the direction of electric field at that particular position. It means if I place a test charge here, then this test charge will experience force in this direction. If I place a test charge Q0 here, this will experience force in this direction. If I place a test charge here, this will experience force in this direction. Are you able to understand ma? So that directions we call it as direction of electric field. Because electric field basic definition is this one only, no? Force experienced per unit test charge is called as electric field. Are you able to understand ma? And make one more note point here. So one more point which we can write is test charge may not move in a curved path. Clear ma? Test charge may not move in a curved path. See ma, here electric line of force, it is curved, no? Electric line of force is curved here. But if I place a test charge cannot move in a curved path. What is the reason? Electric line of force is a curved path. But if you place a test charge at point A, point B and point C, then test charge cannot move in a curved path. What can be the reason? What is the reason? Reason is that for any body to move in a circular path, curved path means circular path only. For any body to move in a circular path, what kind of force is required? Centripetal force is required. But this force, is it giving centripetal force? What kind of force it is providing? Tangential force. So therefore, body cannot move in a circular path. Are you able to understand ma? For a body to move in a circular path, come on, for a body to move in a circular path, there should be some force which is acting towards the center of the circle. Clear ma? So force should be in this direction. Clear? But is force acting towards the center of the circle? No, force is always tangential. Are you able to understand? So therefore here what we will write here force on charge. Which charge? Test charge. Force on test charge is in what direction ma? Is tangential. Clear ma? But charge requires what kind of force? Centripetal force. Charge requires centripetal force to move in a circular path. To move in a circular path. Are you able to understand ma? Charge requires only what kind of force? Centripetal force to move in a circular path. But electric field is providing what kind of force? Electric field is providing only tangential force here. So therefore, charge cannot move in a circular path. So these are some of the properties of electric lines of force. Clear ma? Make a note of them, then we will discuss some more properties. Okay. So let us see some more properties of electric lines of force. So some another properties are these. So a strong charge produces more number of electric lines of force. Clear ma? Strong charge produces more number of electric lines of force. This is also our assumption. Are you able to understand ma? See ma, for example, if I place plus Q charge here, and here if a charge of Q0 is present, then what will be the force of attraction between them? If distance between them is r, then what is the force of attraction between them? Force of attraction is 1 by 4 pi E naught Q0 divided by r square. This is the force of attraction now. Clear? So instead of placing plus Q here, if I place plus 2Q, then what will happen? Force of attraction also will become 1 by 4 pi naught 2Q into Q0 divided by r square. So force of attraction is getting doubled, no? How force of attraction is getting doubled? Because we assume that more number of electric lines of force are experienced by this test charge. Are you able to understand, ma? So if a charge is stronger, then we assume that it will generate more number of electric lines of force. Are you able to understand, ma? For example, if you place Q naught or some charge Q, then let us suppose 1, 2, 3, 4 electric lines of force it is giving. Similarly, if I take a charge 2Q, charge is a double of this one number, then how many electric lines of force it must give? This is 4 lines, no? It must give 8 electric lines of force. So this is our assumption, that's all. Clear, ma? So 1, 2, 3, 4, 5, 6, 7, 8. 8 electric lines of force it should give. Clear, ma? So the stronger the force is, the more number of electric lines it should give. Okay? Make a note up to here. And similarly, one more property we can study is this one. Clear, ma? So if electric lines of force are crowded, then electric field in that region is stronger. Clear, ma? So this is one more property of electric lines of force. Okay, ma? So let us see what is the meaning of this one. See, for example, if this is a positive charge, clear, ma? So 1, 2, 3, 4, 5, 6 lines or 7 lines, let us assume they are traveling away from this positive charge. So if I take one point here, point 1, clear, ma? And if I take one more point here, point number 2, clear? So let here electric field strength or E value, let it be E1, and here field strength, let it be E2. Then can you say what is the relation between E1 and E2? Clear, ma? So here point number 1, here electric field strength is E1, here electric field strength is E2. So at which place electric field strength is greater? What is the relation between E1 and E2? What is the relation between them? E1 is equal to E2, E1 greater than E2, E1 is less than E2. E1 is definitely greater than E2, no? What is the reason? E means what? E means force experienced per unit test charge. So this must be greater when compared to F2 divided by Q naught. That's all, no? Why force of attraction at the first position is greater? Namaskar. Because force of repulsion depends on what? Distance from the main charge. So what is the force formula? 1 by 4 pi E naught Q naught divided by R square. This is the equation for force, no? So force is inversely proportional to R square. That's all, no? Force is inversely proportional to R square. So it means that if this test charge is present at a smaller distance, then it will experience more number of force, and this one will experience less force because it is present at a greater distance. Same concept I can explain like this also. Same concept how I can explain here. The distance between two electric lines force is very small, no? And here distance between the same two electric lines of force has increased. Understand, ma? So this satisfies this condition, no? So if electric lines forces are crowded, then electric field in that region will be stronger. Are you able to understand, ma? So if more number of electric lines are passing through a region, then I will say that electric field in that region is stronger. Otherwise it is weaker. Are you able to understand? For example, if I draw a diagram like this. So question can be asked like this. See, ma. So this is one electric line of force. This is another electric line of force. This is another electric line of force. Are you able to understand, ma? So this is point 1, clear, ma? Here electric field, let it be E1. Here it is point 2, electric field is E2 dash. And here there is a third point where again electric field is E3 dash. Now can you say what is the relation between E1, E2 and E3? What is the relation between E1, E2 and E3? What is the relation? So definitely magnitude of E1 should be equal to magnitude of E3, and both of them must be greater than magnitude of E2. I can write like this, no? Clear, Nama? Because here what are the number of electric lines of force? Same number of electric lines of force are existing at third point also. Clear, ma? But if you see here, the density of electric lines of force is very less, no? Electric lines are very far away from each other. So definitely here I can say the strength of electric field is lesser. So in this method also we can visualize the concept of electric field. Have you understood, ma? Make a note of this one. Clear? So these are some of the properties of electric lines of force. Okay. And also we can discuss that. Clear, ma? No electric line of force, no electric line of force can be started or stopped. What is meant by started or stopped? Or we can say no electric line of force is produced or terminated in space. Clear, ma? Electric line of force cannot produce in any space. Similarly, it cannot be terminated in space also. They must start from positive charge and they must end on negative charge. Clear, ma? And if negative charge is at a very long distance, then these electric lines of force, they terminate at infinity. Infinity means very long distance. So theoretically, the field of any charge, it always ends at where? It always ends at infinity. Are you able to understand, ma? So therefore, what is the meaning of this one? Let us see. So it means that, for example, if it is a positive charge and if it is a negative charge. Are you able to understand, ma? And let us call it as plus Q and minus Q. Okay. Then electric lines of force start here and they end on the negative charge like this. Okay. And wherever it may be, what will be the angle they will be making, ma? They will be making an angle of 90 degrees with the charges. Clear? So this is how the arrangement of electric lines of force will be present. Are you able to understand, ma? Similarly, if you place a positive charge and a positive charge, then what will happen? Then these electric lines of force, they will repel with each other. That is, they try to move away from each other like this. Clear? So this will be the arrangement of electric lines of force. Okay, ma? And if this one is also plus Q and magnitude of this one is also plus Q, then exactly at the middle of these two charges, there will be a neutral point. So what is this N value? N value is called as neutral point. What is meant by neutral point, ma? Neutral point means what? Here if I place any test charge, then force experienced by this test charge will be 0. Clear? Or I can say at this point P. So let this point P. Electric field at point P will be 0. Clear? So if electric field at point P will be 0, electric field is what? Force experienced per unit test charge. Then force experienced also will become 0. Clear, ma? And if Q is greater than this charge is greater than this charge, then neutral point will shift towards the smaller charge. So neutral point will be somewhere here. In which condition? If this charge is bigger when compared to this charge. When this charge is bigger when compared to this charge, electric neutral point starts shifting towards the smaller charge. This is understandable, no? In Coulomb's law, already we have studied all this. Clear, ma? Come on, make a note up to here. So these are some of the properties of here. So this is plus Q and this is minus 2Q. Clear, ma? So first question is, sketch roughly the pattern of electric lines. So how electric lines will be traveling from this positive charge to negative charge? So we should draw a rough diagram. And second question is, where should a test charge be placed so that it experience 0 force? Clear? Can you say how can I draw? Any idea, ma? How can I draw? So what about the magnitude of charges here? This is a small charge and this is a double charge, no? So we have studied one property of electric lines of force, no? If magnitude of charge is greater, more number of electric lines it should produce. That's all, no? So therefore, roughly how can I draw? For example, this is a small charge. So let us assume it will produce 2 electric lines of force. Then this should produce how many electric lines of force? 4 electric lines of force, roughly, for example. Clear, ma? And because this is a negative charge, electric lines of force should travel away from this one or towards this one. Electric lines of force should come towards this charge, no? So therefore, 2 lines, first of all, we will join them. How we will join them? So this is one electric line and this is another electric line. Clear, Nama? So then what about the direction? This should be the direction, no? Electric lines should travel from positive charge to negative charge. So 2 lines are starting from this one and 2 lines are ending on negative charge. But this is a stronger charge, no? It should have more number of electric lines. Clear? Like this. So can I sketch roughly like this? Are you able to understand, ma? So instead of 2 lines, let us take 4 lines. And this should be equal to how many lines? 8 lines. So therefore, what can I assume? So this is another positive line. This is another line going away from this one. Then here total electric lines should be 8 electric lines should be present, no? So 1, 2. So total how many, ma? 1, 2, 3, 4, 5, 6, 7, 8. Can I draw a diagram roughly like this? That's all, no? So therefore 1, 2, 3, 4 lines are produced by this positive charge. 1, 2, 3, 4, 5, 6, 7, 8 lines are produced by the negative charge. So roughly I can draw a diagram like this. Clear, ma? So next question is, where should a test charge be placed so that it experiences zero force? Clear, ma? So this is the line joining 2 charges, no? And what is the distance between them? Distance between them is d. So this is plus q, this is minus 2q. Now can you say where I have to place a test charge so that it experiences zero force? What is meant by experiencing zero force?
Plus 2.
So definitely point should be here, no? Why point should be here? If I place test charge here, then it will be under force of attraction or as well as repulsion, both in the same direction. So this negative charge, this will pull this test charge in this direction. Similarly, this positive charge also pushes this same test charge in the same direction. Clear, Nama? And if I place test charge here, then what will happen? Force of attraction is greater, force of repulsion is weaker. So definitely I have to place a charge here. Are you able to understand, ma? So therefore let this distance be how much? Let this distance be x. Then how can I calculate this x value? See, ma, electric field is nothing but force experienced per test charge, no? So if force experienced is 0, then total electric field also should become 0. Then you calculate electric field here due to first charge and electric field at the same position due to secondary charge. Total electric field magnitude should be equal. So definitely I can say E1 is equal to E2. I can write like this, no? Then what is the magnitude of electric field due to this charge? So this is equals to KQ divided by x square. That's all, Nama? Charge of this one is Q. What is this distance? X. KQ by x square. Then what is the electric field due to this one here at this position? What is this total distance? Total distance is d plus x, no? So therefore I can write k into, now what is the charge of this one? No need of minus here, just we are writing magnitudes, no? Magnitudes. So k into 2q divided by what is the distance between them? D plus x whole square. Clear, ma? So kq gets cancelled. And therefore what is the relation I will get? 1 by x square is equals to 2 divided by d plus x whole square. That's all, ma? So therefore, root 2x is equals to d plus x. I can write like this, no? So therefore, root 2 x minus x is equal to d. So therefore, x is equals to d by root 2 minus 1. That is our answer. Clear? So if I place a test charge at this position, then this test charge will not experience any force. That's okay, ma? Make a note of this one. Any doubt, ma, in this one? Clear, no? So I cannot place a test charge here because it will experience a force of attraction. Clear ma? Test charge net force will be acting in the same direction. I cannot place test charge here also because force of attraction is greater when compared to force of repulsion. Okay, definitely I have to place my test charge here. That is the arrangement. Already we have done this type of question. See, this is the rough sketch of electric lines of force traveling from charge A to charge B. Clear ma? First question is the field uniform or not? Is the field uniform? What is meant by uniform field? Uniform field means spacing between electric lines of force should be equal. This is called as uniform field. So is the field uniform here? Field is not uniform. So answer is field is not uniform. Then what is the ratio of charge A to charge B? How much? How can you identify the magnitude of charges by using this diagram? How can you identify? Clear? So the magnitude of charge depends on what? Magnitude of charge depends on number of electric lines of force. That's all. So this one is generating how many electric lines of force? 4, 8, 9, 10, 11, 12. Clear ma? So 12 divided by, this one is terminating how many lines? 1, 2, 3, 4, 5, 6. So 12 divided by 6 is 2:1 is the ratio. Clear? It means if this is a 2Q, this one should be Q. For example, if it is 2Q, this value should be Q. Clear ma? Third question. What is the sign of QA and QB? Which one is positive? Which one is negative? From wherever lines are originating, that one is positive, no? Definitely this one should be negative because it is receiving the electric lines of force. Clear ma? Then what about the neutral points? What is the position of neutral points? One neutral point should be at infinity. One neutral point should be at infinity. Understand, Amma? And one more neutral point is at point C only, no? Clear? What is the reason? Because this magnitude of this charge is smaller, magnitude of this charge is bigger. So definitely neutral point must lie on this line and it should be closer to the what you called smaller charge. Are you able to understand, ma?